Hello everyone and welcome back to Biology with Mrs. Evans. Today we are going to talk about pH. So last week I asked you to tell me in your KWL chart what you knew about pH, what you knew about the pH of an acid and the pH of a base. So today we're going to talk about the pH scale. So the pH scale simply is a measurement of hydrogen ion concentration. And I'm going to talk about that again in a minute. But first I want to talk about basically what happens. So in water, basically 1 out of every 550 million water molecules are going to dissociate. And what that basically means is they are going to split apart and they're going to form two ions here that I have on the slide. So you're going to have a hydrogen ion and a hydroxide ion. And again, remember, pH measures the hydrogen ion concentration. And I'm going to advance to the next slide so we can talk about that. So pH measures the concentration of hydrogen ions. So if there are more hydrogen ions than there are hydroxide ions, just think of it as a scale tipping this way, then the substance is going to be an acid. If there are more hydroxide ions compared to hydrogen ions, then the substance is going to be a base. So again, think of it as a scale. So if it tips to the left because it has more hydrogen ions, then it's an acid. Then if it tips to the right because it has more hydroxide ions, then it is a base. Water is neutral, has a pH of 7, and what that means is that there are equal hydrogen ions and hydroxide ions in pure water. So the pH is 7, which is neutral again because the concentration is equal. So again, when somebody asks you what does the pH measure, know that it measures the concentration of hydrogen ions, and it's basically a comparison as to whether it is an acid, base, or neutral. So the pH scale, you probably know that it ranges basically from 0 to 14. And pH of 7, again, you should know is neutral. Example of that would be water. And then anything below 7 is going to be an acid. You should also know that as you move to the left on the scale, so the smaller the number, the more acidic the acid, the stronger the acid. And then bases are anything above 7, so 7 up to 14. And again, this time as you move to the right, so this time the higher the number, the more basic the base is going to be, or the stronger the base it's going to be. And the pH scale, you should know, is a logarithmic scale. So that means if you go from a pH of 2 to a pH of 3, then that tells you that pH of 2 is 10 times stronger than a pH of 3. And here I've on the board or on the slide here I have pH compared to a pH of 3 compared to a pH of 6 is going to be 1,000 times stronger, because again each level is 10 times basically difference between one level and the next. So again, what you need to know is the pH scale ranges from 0 to 14. Most of the time we don't include 0 because there's not really too many strong acids like that. So here I have a picture representation of the pH scale. So you will want to write this in your notebook. Go from 0 to 14. 7 you're going to want to label as neutral. It should just be 7 here. And then basic is going to be everything above 7, so 7.1 on is basic. And again, you need to know that as you move to the right, these are getting stronger. All right. And then acidic is everything below 7. And for acids, as you move to the left, it is getting stronger. And then I have some examples of items that have pHs. So again, water, if it's pure, is going to be 7. Again, it's going to be 7 because there's equal hydrogen ions and hydroxide ions. And then gastric juices, so the juice that is in your stomach has a pH of 2. And again, that is going to be 100 times stronger than tomato juice, and that has a pH of 4. And then some basic substances, your blood is slightly basic, hand soap, household bleach, and oven cleaner tops out at about a pH of 14. So we're going to do a lab with this to test pH. So again, you need to know pH measures the hydrogen ion concentration. If there's more hydrogen ions, then it is acidic. If there are more hydroxide ions, then it is a base, or is basic. That brings us to buffers. So we talked about homeostasis. Remember, homeostasis is the ability to maintain an internal environment despite what's going on externally. And in order to help us or help organisms maintain that, they use buffers. So a buffer is a weak acid or a weak base that is going to react with a strong acid or strong base, sorry. And basically what it's going to do is it's going to level things out. It's going to prevent these sharp changes. So if you take human anatomy and physiology, you'll talk about how your body deals with the strong acids that are coming from basically the slurry that's coming from your stomach into your small intestines, how it's going to buffer that change, that strong acid, to bring it up to a much more manageable pH as it enters your small intestine. So just know a buffer is a weak acid or weak base that is used basically to neutralize a stronger acid or stronger base, and that again is necessary to help us maintain homeostasis. So we're going to be doing a lot with pH in lab, so I'm not going to go into a lot of details. So have a great day, everyone.